Okay, hi everyone. So this is a lesson for Chapter 3 Dynamics for Sec 3 Physics. We want to go through the basics of what types of forces there are, and then after that we will be ending off with doing a free body diagram. Okay, so what is a force? You've learned in lower sec. Force is a push or pull. The unit for force is Newton. Make sure you write it with a capital N. Some types of forces you will know. Okay, you need to fill this up in your notes. Okay, gravitational force, another name for gravitational force is weight. So these two can be used interchangeably. Both refer to the same thing. Frictional force, okay, this is the force that opposes motion only when there's contact. Okay, similar to friction, this is air resistance. It's due to air molecules rubbing against the surface. As long as an object is moving in the presence of air, you will experience air resistance. And the air resistance will be opposing the motion. So you can imagine yourself standing still, and when you're running, so when you're running you feel the wind against you, that is air resistance because you're running into the air molecules. So the air particles are acting a force on you. So that's air resistance. Okay, other two forces you need to know that are around are electric force, or sometimes it's known as electrostatic force. Okay, and then there's magnetic force. Okay. And in lower side, you already learned between the two things, contact force and non-contact force. So I will not go through the details. Basically, so for contact force, it's basically when there's a contact. Non-contact force, that means it's acting from a distance. Also in lower sec, you learn about the effects of force. So I'll quickly run through. A force can cause an object to start moving or stop moving, increase or decrease speed, and also can change motion and can change the shape and size. So I am not going to go through the details here. This is something you have already learned. Okay, this is the part that requires your attention more. Okay, it's called free body diagram. So what it basically is a diagram where you can draw all the forces acting on the object using arrows. Okay, so the length of the arrow by right will show the size, how big the force is, and also more importantly show the direction, where is it acting. So forces acting on the object will have an effect on motion. Later we'll find out how. So it actually will cause an acceleration. Okay, so once you have all the forces labeled, you can then determine the resultant force, basically the result of all the force. So let's look at example A here. Okay, we have a book resting on a table. For all objects on Earth, you will see that as long as there's gravity, there will be a pull down to the center of the Earth. This is the gravitational force, or in short, I just write weight. So there's a force acting down, and then there's a force because the object is on the table, it experiences a force upwards. We call it normal reaction force. So later I'll go through in more detail what this is about. Okay, so to simplify the diagram, usually we just simply put the book represented as a dot. This is what the free body diagram should look like. There should be a dot, and then you apply all the forces in. I didn't draw very clearly, but by right, both the size, the length of both arrows should be the same because they balance out. The object is not moving, so both forces should be the same. Another thing you're familiar with is actually we learned ALP, is the aeroplane. So in the aeroplane, right, you'll see that there are the four forces of flight. Okay, the forward force we call it thrust. The force you have learned already that always acts on any object near the earth is weight. The force that is able to produce lift due to Bernoulli principle. Okay, and then we call it drag, but in this chapter we will be calling it air resistance. It is the same thing as well. So if we simplify the diagram to a free body diagram, it will look like this. Okay, thrust, lift, drag, and weight. Okay, the size of my forces are not drawn to scale. By right, the thrust should be bigger so that you overcome the drag, so that the plane can be moving forward. But we're just not going to ignore that for now. Okay, to help you understand better, I have created this. So we're going to go through bit by bit what each force is and where it will act on. So for weight, suppose I have a box on the table or on the floor. The direction of the force will always be acting downwards, no matter which orientation it is. So even if the box, in this case, is on a slope, the force for the weight, right, it doesn't act this way, but acts still perpendicularly downwards. Okay, it doesn't change. And same if I have an object hanging, the force will still be acting downward as well. Okay, so no matter the orientation, the force are always acting downwards for weight. Now, normal reaction force. The word normal, if you can remember in light, when we asked to draw the normal line, the word normal is a maths term. It simply means 90 degrees. 90 degrees from the normal, or from the surface. Sorry. So in this case, if I have an object placed on the floor, it will experience a normal reaction force. This force is always there when something is in contact with a surface. So in this case, I can draw it going up. I can draw an N to represent normal force. In this case, the force in this case will be from the slope. So instead of drawing straight up, it will be 90 degrees in this case. So right, in this case, I guess I should make sure to show you that it's 90 degrees here and show you it's 90 degrees here. So you can see that the normal force here is perpendicular to the surface. Okay, so this is how the nature of normal reaction force is. As long as an object is in contact with a surface, you will experience a normal reaction force. Okay, the next is frictional force. So I tried to draw a moving object. As you can see, if this object is moving to the right, where is the frictional force? In this case, the frictional force will be along the surface here. Between the two surfaces, you can just call it small f to represent frictional force. Okay, so you will experience a frictional force on the opposite direction. Same, if I have an object moving up slope, the force experience will be downwards in between the surface. This whole point of learning this is to show you how each of the forces act. And finally, if I have an object that's falling, if you see an object falling down, right? It doesn't experience friction because it's not in contact with any surface, but actually it experiences this thing called air resistance. Okay, so I'm going to draw upwards to show air resistance. Air resistance also is present when an object is moving, like we see in the airplane just now. So it need not be upwards all the time, but in this case, because the object is falling down, the air resistance is going against it, so it is upwards. Alright. The next thing we will need to learn is tension. So in this case, tension, right, acts on a string, a rope, or anything that is being pulled on. So in this case, I have a string being hung on the object. The tension force experienced by the object, by the box, right, is actually this way. So I'm going to write T as a short for this. And in a case where object is tilted to one side for some reason, okay, the force will be along the string. So it will be T this way. So this is just a quick introduction to some of the forces, so at least you know how some of them behave. Okay, so if you combine them together, this is what it will look like. In situation 1, if I have an object that's falling, how many forces are acting on it? Okay, the first force you will see that it will be acting is weight. Weight is pulling the object down. But it's also experiencing another force, especially if there's an atmosphere, right? So in our Earth's atmosphere, there's air, and so you will experience air resistance. It doesn't experience normal reaction force because it is not touching a surface and it's not experiencing friction, or we should say that air resistance is a type of friction. It is the main thing that's experiencing. Okay, the next thing maybe I write this to help you see clearly. Okay, a second situation can be when let's say a box moving upslope. So how many forces are acting on it? It's actually quite a bit. So first you would know the easiest one, weight. Weight acts downwards. The next thing you'll see is normal reaction. I'm going to draw it from the dot to show it clearly. Normal reaction is 90 degrees from the surface. What else? If the object is moving upwards, it will experience a frictional force in the opposite direction. So we have friction here. Right? And actually, if it's moving, for any object that's moving, it will experience air resistance as well. So I'll just add one more arrow here to show you there's actually air resistance. So you can see there are many forces just for this object to be going up. And of course, if an object is moving up slope, there's probably a pulling force pulling the object up. But I'm not going to include that for this case. Alright. Another example, if I have a pendulum that's swinging, which you have done before in the lab. So if let's say at this point where it is swinging at the top, what forces will you experience? The first obvious one will always be weight, the X downwards, tension, the X here. If you're saying that the object is swinging down, I can also add one more force here where it's air resistance if the object is moving down. But if the object is stationary, then this will not be present. Okay, so this sums up for this short video. It's mainly to help you introduce you to all the different types of forces. Okay, any questions, you can just text me. Thank you.